So hello also from my side. Just thank you very much, Stella, for introducing me. Just a small change. I'm not a professor. I'm just finished my PhD in the Aristotle University of Thessaloniki, and together with Eleftheria, my colleague, we are postdocs working in the coordination team of GRECO EU project, which I'm going to present to all of you today. And also, thank you very much for being here and for your attention today. So, first about the project overview. It's called Innovative Bio-Based Biodegradable Recyclable Safe and Circular Food Packaging. Its acronym is GRECO. Its duration is 4 years. It started in 1st of May in 2025 and is expected to finish at 30th of April of 2029. Professor Nikolaos Bikiaris is the project coordinator from the Aristotle University of Thessaloniki, and the whole consortium consists of 21 partners, together with one affiliate entity of Corbion in Thailand. As you can see, all the partners are equally distributed all across Europe. We have partners from 12 countries, such as Greece, Spain, Slovenia, France, the Netherlands, Croatia, Turkey, Estonia, Italy, Germany, Finland, and UK. The types of organization of our partners that are consisted in the consortium are 7 research organizations, including university and technology institutes such as Aristotle University of Thessaloniki, AIMPLAS, University of Maribor, IPC, VTT, University of Almeria, and University of Warwick. We have 6 partners involved in the materials technology production, such as Comexi, Corbion Group, Condensia, Worley, Biomi, and Nanotipos. Also, we have 3 packaging manufacturers and end user, which is the Innotech Group. We are Biofood and Pinar. Also, 4 partners specialized in regulatory standardization, dissemination, communication plans, such as UNE, ENCO, ARTSA, and European Bioplastics. So the problem that the GRECO project aims to address and tackle is the plastic littering coming from food packaging waste. As you all know, there is a significant amount of food packaging waste currently coming from the market, which is not properly exploited after its life duration. So what the GRECO solution is to provide to the society and the market next generation materials. This is going to be achieved firstly by the use of bio-based monomers such as succinic acid, adipic acid, and azelaic acid, meaning that monomers that derive from renewable resources and not from fossil-based ones. From these monomers, in using green catalysts, we're going to synthesize some prepolymers and some copolymers together with PLA, polylactic acid, incorporate some green additives in order to prepare some compounds with enhanced antioxidant and antimicrobial properties, and further enhance these films that are going to be produced from extrusion via various surface treatments and bio-based coatings, which is going to be presented later, and finally be demonstrated in 4 food value chains, which is cheese, dry fruits and nuts, meat, and other dairy products. So overall, what GRECO aims to demonstrate is the life cycle and techno-economic feasibility of greener and safe bioplastic that incorporate the safe and sustainable by design strategy. All this is going to achieve, as I mentioned, by the synthesis and preparation of innovative bio-based, biodegradable, and recyclable packaging materials based on new PLA copolymers, coatings, additives, and green catalysts, of course. As I said, they are going to be validated in 4 different food value chains. And what we aim to and aspire to achieve is to prepare and produce fully circular PLA-based materials that meet the application and market needs and requirements. Our methodology scheme, first, we're going to start from bio-based monomers. We're going to prepare some polymers using different diols, such as ethylene glycol, propandiol, and butandiol, to obtain copolymers and copolyesters with different properties, different molecular weights, in order to see some differences and how we can exploit them further. We're going to prepare some pre-polymers and then compolymers, compounds and blends, also using green catalyst in order to replace the existing metal-based catalysts that are typically used in the synthesis of these bioplastics. From this, we're going to incorporate some bio-based additives and extrude them, scale up using extrusion, and further enhance them with bio-based coatings and surface treatment application, and then validate them across food value chains. Also, in the GRECO project, we're going to incorporate some digital tools and SSBD strategies, evaluate the biodegradability, recyclability, as well as environmental, social, and economical aspects of our projects, and finally, prepare a communication, dissemination, and exploitation plan. Our work plan is divided in seven work packages. The first one, which started in May, involves the technical market, materials, and process requirements, meaning that we need to find all the specification requirements and also do some modeling of our polymer properties. After that, we're going to develop the biodegradable and bio-based PLA-based pre- and copolymers. In month 6, we're going to start with the development of functional coating and advanced surface treatments. At the same time, we're going to evaluate the recyclability and biodegradation of our materials, then scale up them in month 25, and of course, find ways and prepare a plan to exploit this commercially in the market. The implementation stage now of GRECO. First, we're going to define the processes, end users, and market requirements. Once all these, together with the modeling of the properties, is finished, we're going to produce the copolymers, the green catalyst, the bio-based coatings, the additives, and the compounds, assess and evaluate, of course, their properties and characteristics. And from these selected materials and technologies will be transferred from TRL 5 to TRL 7. And the final stage involves the validation of the packaging project together with the end users, as well as the assessment of the end life aspects such as recyclability and biodegradability. Okay, now some more information and insights about the copolymers and our structures. As I said, the main polymer we're going to use is polylactic acid, which is fully bio-based, biodegradable, and recyclable. We're also going to use some other bio-based monomers, some decarboxylic acids, such as adipic acid, succinic acid, and azelaic acid. We're going to copolymerize them into prepolymers using 3 different diols, ethylene glycol, propandiol, and butandiol. From these prepolymers, we're going to then synthesize copolyester with lactic acid via the ring open polymerization, using also green catalyst. And as you can see, we're going to obtain different structures of copolymers and copolyesters. Now, our coating technologies and surface treatments involves 3 different surface treatments, which is a plasma treatment, e-beam application, as well as lithography. Bio-based antioxidant and antimicrobial coatings, such as plasma treatment, will be developed from the University of Maribor, our partner in Slovenia. The first technology will be transferred from TRL 5 to TRL 7, while the plasma treatment from TRL 6 to TRL 7. University of Maribor has also developed a methodology at TRL 5 at this moment for the conversion of polyphenols into polysaccharides, such as puranorchitosan. And there is also a patent available if any partner right now is interested to contact, and also it will apply a 2-step plasma treatment for our films. After that, we're going to develop some demonstrators for 4 different food value chains. This is expected and it's scheduled to start from 1st October of 2027 until the completion of the project. So first, our demonstrator is the dough bags for dry nuts, whereby BioFood is responsible for the development of this demonstrator. Once developed, the shelf life will be tested, as well as some microbial and organoleptic studies at various and different storage periods. and also some other tests, including the determination of peroxides or p-anisidine. Thermoform trays now will be developed again from EUBP food for fruits and red berries. After the completion, the oxidation freshness and microbiology will be monitored. For dairy products and especially cheese, our partner in Turkey, Pinar Dairy, is responsible. Mostly they will work with type of cheeses such as cheddar, Gouda, processed and burger cheese for the validation process. And after sealing, dye test will be applied for the control of the sealing, and also some extra microbial tests and other analysis will be, of course, conducted by our partners. Lastly, again, Pinar Meat in Turkey will also develop demonstrators for salami, and again test the material structure and other permeability tests against oxygen and water, and also other will monitor some other properties. And lastly, for meat, especially for minced beef, Pinar M will also prepare some meat packages from the use of thermoformable films and the application of modified atmospheric packaging or bags films for vacuum packaging. Okay, as I said, work package 4 involves the evaluation of recyclability of our materials. We're going to test both mechanical and chemical recycling. The mechanical recycling will be done by IPC and it involves mainly sorting, reading, washing, drying, extrusion, and volatilization. And chemical recycling will be tested via also microwave reactor and also solvolysis in an in-house pilot line by our partner AIMPLAS in Valencia of Spain. And it's expected that all of our materials be fully recyclable in both ways. Now, at this point, I would like to ask some feedback from our audience, which comes mainly from the industry. If you can foresee any potential industrial partnerships on scaling up our food value chain demonstrators, or you have in mind some production strategies for the European marketing of food packaging products. Also, in terms of scientific feedback and knowledge exchange, our views and opinions are most welcome in terms of the biodegradability testing methodologies, as well as coatings and fractionalization, and finally the recyclability assessment approaches. If there's any recommendation, please feel free to contact us or anything else you have in mind. Lastly, about the applications and impacts. Which market applications do you foresee that, or do you, in your opinion, are most urgent or viable? Are there any other end user requirements such as life, safety, or labeling we should prioritize in the lifetime of GRECO project? And finally, what do you see the biggest opportunity for exploitation in the sector that you are currently working? As I said, which applications we should prioritize, and also what market barriers do you foresee that would make difficult the adoption of our developed materials after the life of a GRECO project? Lastly, please, if you would like to follow the GRECO project in its website or in the Zenodo database, as well as in the LinkedIn social platform, we will be very happy to have you on board, and you can follow the latest news and results, as well as research that we frequently publish in our website. Thank you very much for your time. I'm free to any questions, and I hope that you like the presentation and you are interested in our project.